Did you know that by 2030, AI is expected to contribute over $15 trillion to the global economy? AI and machine learning jobs are among the fastest growing in tech, with demand skyrocketing year after year. So if you're not already learning AI and machine learning, now is the perfect time to jump in. But before that, I have a quick information for you guys. We are conducting an absolutely free AI, machine learning, and generative AI masterclass where we share a proven 3-step framework to help you crack AI and generative AI jobs, paying over $250,000. We have helped so many learners land their dream jobs in AI, machine learning, and generative AI. So if you want to be one of them, join this masterclass. You can register through the link given in the description below. So now let's get started.
AI. Okay, so when I say life cycle of AI, just to keep it simple, the life cycle of AI starts with data ingestion. Okay, and then it goes ahead and we try to go ahead and clean the data. Okay, clean and pre-process the data. Okay, so we clean and pre-process the data that we have. Once we clean and pre-process the data, then we go ahead and select an algorithm. So we go ahead and select an algorithm. Once we select an algorithm, basically based on the type of output that is being required, we will go ahead and select an algorithm, right? So suppose if it is a continuous variable, I would like to know from all of you, what should be the algorithm that we should select for continuous one? Continuous output, we can call it as regression. And if we have category or class as a model which we want to go ahead and predict or build, classification, we always look into the output variable. Okay, and then we also have got something called as clustering, wherein we are not sure, like we are not being specified what to do. This is also classification, but this is non-supervised, or you can call it as unsupervised. This is also a type of classification. Classify the data. Okay, so we select an algorithm which will be based on regression type, model we want to build, or classification or clustering based on the type of output variable that we have in place. Okay, or we if we do not have output variable, once we go ahead and select an algorithm, what basically happens is, if I can just put it this way, we build a model, right? So a model is built. Okay, so build a model. This is what happens here. Once the model is built, it's very important, once the model is built, that we go ahead and check the model performance. Okay, so whatever data we had, the data that we ingested, always remember the data will be, suppose this is the data, and suppose I'll just give an example. Suppose there are 10 values that are there. Okay, so the first value was 1. Suppose row number 1 to row number 10. So if we have 10 counts, okay, or you can say 10 data points that we have, which is spread across multiple features. Okay, then we go ahead and always do one thing. Of whatever data we have, I'm just giving you a simple uh, set. Okay, so we split the data. Okay, we split the data at the initial level only into train and test data set. Train data, and the another data that we call is test data. Okay, now why is this required? Because with the help of training data, like the input data, we are going to go ahead and build a model. Okay, so when we build the model, we go ahead and take a sample data. So we have two data. We always divide the data. Okay, and what is the division type? We will look into that. Right now I'm just saying we split the data into two types, two segment rather than two type. We split the data into train and test data. We build the model. That basically means, when I say data, what will the data have? It will have input features, right? Or you can call it as independent variable, and it will also have output features. Okay, or you can call it as label or target, right? So at the time of training the data, you are going to show both the things, right? You will show the input as well as you will show the output, and then the model will go ahead and understand the pattern in the data with the help of statistics, right? Or you can say with the help of those algorithms which are built on top of those mathematical equation. So it understands the pattern, it remembers the pattern, and a model is being built which encapsulates the information between input and output. Now, once the model is built, it's very important to test the model, right? So to test the model is very important. This step is called as evaluation of a model. Okay, so you build a model and then you evaluate a model. Okay. Now, when you evaluate a model, what do you do? I'll just keep it simple. So suppose now, if you remember, I had two data sets, train and test. Okay. Now, what is the next thing that I have? I want to test my model. How is it performing? Now, if I want to test the model, how is it performing? I will show the input feature. Okay. And I will ask the model, since the model has already been built, right? The model has been built, right? So I will show the input feature. Suppose this is my model. I'll just put it, suppose here M. This is my model. So I will go ahead and feed this input to this model. Okay. Which is coming from where? Which is coming from my test data set. Okay. Now test data set. Now my question is pretty simple. Does the test data set has output also or not? Does it have output or not? It has output because it is being taken from the original data set, right? This was my original data set, and the original data. Now I'm just talking about what you can say. Suppose I'm talking about supervised machine learning. Okay, do not consider it to be unsupervised. So just to keep it simple, it will have the output also, but I'm not showing that output. I'm hiding that output, which is available from the test data set. I'm just showing the input to the model, and now I'm asking the model to predict the output. So what happens here? The output gets predicted. Okay, so we predict the output. Now whatever output we predict, we compare it with actual output, because we are testing the model, right? So we compare this with actual output. Is it okay? Just to give an example, suppose I'll just put it simple. Suppose I have a output column, okay, or I can say the target column. Suppose the person is diabetic, then it is 1, then non-diabetic 0, then again diabetic 1 and diabetic 1. Okay, suppose. Okay, so this were the labels that were supposed there in my test data set. Okay, test data set. These are my output targets. Okay, now this is what we call as, tell me, actual output. Okay, and these are basically dependent upon blood pressure, diastolic blood pressure. Okay, family history, and all those things will be there. So this is actual. And now let me just tell you what came out of the model. Okay, so suppose I have to predict the output. So I have predicted output, right? I showed all the feature and I got a predicted output. So suppose my predicted output is 0, 1, okay, or I'll just say 1 and then 0 and then 1 and then 0. Okay, now I'm going to ask you, is 1 equal to 1? Yes or no? So the first answer is correct. The model was able to predict the correct thing for the first value. What about the second value? It predicted correct. Third value also it predicted correct. But the fourth value, it did not predict correctly, right? If I ask you in a simple term, what is the accuracy? So you will say how many were predicted correct out of all the data points. So if I ask you, you can say that this is 75% accurate. I'm just giving an example. Okay. So now if you're happy with the performance, so suppose this is one of the evaluation metrics. Okay. So this is what we call as evaluation metrics. Okay. So you evaluate a model against a matrix. Okay. And that matrix can be accuracy, or there are so many others. And if you are, the next step is, this is where the testing happens. Okay, now once the testing happens, I'll just put it stepwise. So this is step number 1, this is step number 2, this is step number 3, this is step number 4 of select an algorithm is basically step number 3 only. Then we come step number 4, then we go to step number 5. And once we are done with this step, then we will go ahead and check whether we are happy or not. So if you are happy with the performance, you will go ahead and deploy the model, right? Deploy the model for maybe your business use case, or maybe for the end user, for whatever is your business use case. Okay, right? Is it fine? So this is what we can call it as step number 6. I hope that makes sense, everyone. So this is a basic life cycle of any data science, or you can say AI project. Okay, now let me just get started with the first step, which was about ingestion of data, right? So we'll look into this aspect. So there is a one nice diagram that we have that can help us understand a lot of things. The first thing is type of analytics. Okay, when we say analytics, basically you need to understand the data, right? You need to analyze the data. So basically, If you look into this axis, what do we have? We have three levels: hindsight, insight, and foresight. Now, just to keep it simple, suppose you got the data, okay, and suppose you have a data wherein the company is saying that the sales are going up or it is going down, or suppose you have the data from the telecom where the customers are leaving or customers are joining. Okay, so suppose you have this kind of data. The first thing, if you have a data in hand wherein you do know that the customers are leaving the system, what is the organization going to go ahead and tell you? They are going to tell you, go ahead and try to find what happened. When you try to find what happened, this is what we call descriptive analytics. What happened basically means you try to go ahead and create tables, visuals, charts, and try to find what has happened just by looking at the visual. This is coming under hindsight. Okay, now comes the next part, which is something has happened. That's okay. You looked into the descriptive analytics using visualization tools. You went ahead and looked into descriptive analytics. Now, once you looked into descriptive analytics, you would be interested to find why did it happen, right? And this is where we make use of multiple project management tools like fishbone diagram, where we try to go ahead and draw cause and effect diagram. Here you can see that this is more like a fish, right? So what do? You write all the causes. Okay, just to keep it simple, you write all the causes on this side. Like, just to keep it simple, if I show you poor customer service or cheaper alternative available, where the reason for people leaving the system. Okay, now what were the cause? Okay, the cause is people, the cause is equipment, the cause is maybe distance. I'm just giving an example. Okay, so there are multiple causes, so you will go ahead and draw, just to give an example, draw a diagram wherein you will write all the cause, and then you will go ahead and write what effect did it go went ahead and did, right? What was the outcome, okay, of the problem because of this causes. So this is a type of tool. Just to give an example, this is how the system functions, where you try to go ahead and diagnose the issue. Similarly, how doctor goes ahead and does, right? When you go to a doctor, first he asks what happened, then he also tries to understand why did it happen. Did you go to some place? Okay, suppose if you have a cold, they do ask you, how did you got this cold? Okay, so they do ask this thing. Once the diagnosis is done, then they try to predict. Okay, so why did it happen? We are able to understand. Now, what will happen? Is it serious or is it non-serious? I'm just giving an example. So just to keep it simple, will the customer go or will the customer be there in the system? So what will happen? This is where our predictive machine learning system comes into picture. Okay, so the first was hindsight, second is the insight, the third is also part of, you can say, insight only, what will happen. Okay, or you can call it even part of foresight, right? Or just to put it simple, you are trying to create a model, right? This is predictive analytics, right? So you can call it as a part between insight and foresight, right? So what will happen? Will the customer go? So if the customer goes, how can you go ahead and make it not go from the system, right? So what's the best method to retain the customer? This is called as prescriptive. Doctor never says you that if you take this prescription you will be 100% okay. They will say, take this out, we will see what will be the result after 3 to 4 days, right? This is how they say. So this is prescriptive. How can we prevent it? We are not sure whether it will get prevented 100% or not, but how can we prevent it? We will try to go ahead and check it out. So this is where hindsight, insight, and foresight, predictive analytics comes into picture. Okay, so predictive analytics is still from the past data. Making sense? This is building a model, right? Once you build the model, maybe a regression model, you can see a line, or maybe a classification model, or maybe a clustering model. Okay, so once you build a model, then you will go ahead and try to use this model to help you prevent the things that are going to happen. Okay, so I hope this diagram makes sense with respect to descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. Okay, all these four words are very different to each other. Okay, now what is data science? You must be hearing this word data science everywhere. So data science is a science which will help you learn the data, right? That simple as it can get, right? Now, what do we require for data science, which helps you to build AI system, to be very frank? So the first thing that you need to have is knowledge of programming. The second thing that you need to understand, to be very frank, if you want to be a great if you want to be a solution developer, knowledge of mathematics, even if it is not that, that's okay. But if you want to be a machine learning engineer, where you want to understand what is happening in the machine learning aspect, right? Then you need to know mathematics, statistics, and even machine learning algorithms. And finally, one more important thing, everything is about data, right? So the point is everything will be surrounded by data. Okay. So what is data science? It is more of a coherent part of machine learning. Okay. Wherein you have again data coming, then programming, wherein you go ahead and write a program. One important thing that you need to be aware when you want to go ahead and take data science as a course is always remember that domain knowledge and having a subject matter expertise is very important. So, to be very frank, if someone helps ask me to create a machine learning model which is going to go ahead and predict the person to be a cancer patient or a non-cancer patient, before I want to go ahead and build a model, I need to understand the data, right? So, for that, it's important that we have the domain knowledge or we have the subject matter expertise which can help us understand what is the implication of this data, right? This is really important. Okay, so it is more of an interdisciplinary thing wherein programming, maths and algorithm, basically understanding the equations, okay, basic mathematics, okay, stats, wherein you go ahead and analyze the data, visualize the data, and then build a model, and then making use of subject matter expert to be able to go ahead and build a AI model. So this is basically what we call data science. Okay. Now, when we say data, we need to be aware about the databases also. It would be a great thing if you are aware about databases. And then you need to have knowledge of at least one of the programming language like Python or R, or there are others also like Scala or Julia. Okay. There are other options also available. Okay. Now, just to take you ahead, there are different stages. If you remember, I did say about data pre-processing, model planning, then model building, okay, and then presenting the result, or you can say evaluating the model and then presenting the result and then deploying the model. So everything in data science, you can say, starts with business case. Okay, so why do we require to go ahead and build a model? So what is the use case? There is some issue, right, which we will try to go ahead and solve. So the first thing comes with business case and discovery. The second aspect is about pre-processing the data. Then comes model planning. Now, how is model planning different from building? In this, you try to go ahead and find which model is suited for your data. So in regression, there are n number of models, right? So you try to suppose first you will go ahead and decide whether it is supervised or unsupervised, in supervised, which category it comes into. So you plan and then you build the model. So many a times in the regression, you have multiple algorithms to choose from. For regression machine learning also, you have multiple algorithms to choose from. Suppose you went ahead and selected three algorithms. Okay. And after selecting three algorithms, you were suppose I'm just telling you, suppose from the first algorithm, you got an accuracy of zero point 0.9. Okay. From the second, you got an accuracy of maybe 0.95. And from the third, you got an accuracy of, you can say, maybe 0.88. So now out of these three, the best performing model as per accuracy seems to be this. So the second thing is you build the model, and many a times you build multiple models. Okay. And every model will have its own evaluation. Okay. And if you are happy, then you will go ahead and select the model. Okay. So you build the model basically means you train the model and test the model. And the best model out of, if you have created multiple models, you will go ahead and select, is called as model selection. Okay, once again, yeah. Similarly, you also have to present the result, right? So when you want to present the result, basically you will go ahead and create a visuals, okay, wherein you can present the result of your model to the stakeholders. They can be end users, they can be government organizations, they can also be your company employees, for which you are going to go ahead and make them use the model. If once the presentation is done, then you will go ahead and deploy the model, and you will automatically, when you deploy, you will always look into the optimization aspect, whether the model is performing up to the standard or not. If it is not, you can redeploy the model by going through all the stages again. Just taking you ahead, when we say business case and discovery, this is very important. The most important thing is, what do you want to achieve? When you decide what's the end goal, before that you will also look into discussion with the stakeholders, right? Who are going to use this model? If you can have a discussion and try to find what do they want from the model. Do they only want the result, or do they want the result that is more of responsible in nature? Okay, not unethical. Okay, so you need to have discussions with stakeholder who are going to use it. Very important thing when you look into a business case and try to discover the issue in the business case, you also need to look into people who have already attempted in the past. This is a very important thing. People who have attempted, they might have failed, and if you can gather insight on how did they fail, okay, so that you can be proactive, that can be a very good thing. One more important thing, how much budget and time we have. Many a times machine learning models, to be very frank, sometimes it may take 7 days to train a deep learning model. Trust me, when it is going to take so much time, it's important that you look into budget and time that you have. Okay, and finally, so budget and time, budget basically is going to help you understand what kind of machine learning model can you go ahead and build. Okay, fine. Will it require a GPU or a CPU? Based on that, you can go ahead and decide what is the requirement of the customer. Okay, or maybe the business. You need to understand so that you can manage the time and the budget. Similarly, one more very important thing is what kind of data you have. So if you are going to give garbage into the system, it is actually going to go ahead and give you a garbage out. So the most important thing is the kind of data you have available. Okay, if the data quality is not good, okay, if the data quality is not good, you cannot go ahead and seriously create a model. Creating a model is of no use if the data is not good, right? So it's important that whatever model you want to build, first you look into the data. I hope that makes sense. So suppose there is an HR, okay? HR have multiple tasks to achieve, right? In an organization, the most important task right now in a work from home environment is to take polls. You must be aware, right? Everyone, they do take a lot of polls, right? When they take polls, do you think that we people are really serious? How many people are serious when, suppose if they are going to ask, are you happy? 99 or 100% people are going to say yes, right? So why are they saying yes? First thing, they do not want to label themselves as they are not happy. Second thing is they do not have time. When they say no, they don't want people to come and ask why I'm not happy, because they maybe people are thinking that we are not going to get the result out of it, right? So the point is, suppose the HR is going ahead and asking you to go ahead and take the feedback. Rather than that, it would have been really nice if HR would have identified people who are serious, okay, or you can say people who are stakeholders, who are worried about the system, and they are from each and every segment of the company, right? And suppose rather than taking feedback from 100 people, okay, on the floor, if they would have taken 10 genuine feedback, don't you think that data is far better than the feedback that has been taken across the team? So rather than taking the feedback from 100, what if we take the feedback from 10? Is it not better? It's better, right? Now the problem is machine learning only works on data. Okay, so when it works on data, you have only got 10 samples. And suppose, just give an example, it can only work when you have sufficient amount of sample. Now the problem is those 10 samples are pretty good, but my machine learning model will not be able to cater to that kind of thing. Okay, so right now the trend is using GPTs, people are able to generate synthetic data. Synthetic data means a data which has been augmented on the real data itself. I hope that makes sense what I'm saying. So synthetic data generation, wherein rather than taking the feedback from 100 people, what if I only have 10 genuine feedback and try to go ahead and create fake data which resembles to real data? And then I can train a model, though the data is not real, but it is still far better, okay, as compared to the data that might be coming from people who might just be filling it for the sake of filling the form. Making sense what I'm saying? Okay, now let me just take you to the next slide. So now comes the next thing, which is about data pre-processing. Now, when I say data pre-processing, there are different things in data pre-processing. First is mapping the data. Second is cleaning. Third is transformation, and then samples. Guys, those all processes are being used by machine learning. Okay, models. Okay, when we want to create a machine learning model, we do go through this. Okay, so first is map the data, clean the data, then the next is transform the data, and finally we sample the data. Okay, now what do we mean by mapping the data? Maybe the data is there in the database. Okay, maybe the data is there on some public repository. Okay, maybe the data is, you can say, there in someone else's system, and I want to go ahead and pick the data. Okay, maybe it is connected via a network. Okay, so the first thing is, if I want to build the model, first I'll get a copy of the data in my system, local system. Okay, I can get it anywhere, but I need to read the data, right? So I can make use of different libraries like pandas. Okay, we can use to go ahead and read the data and basically map the data on our application where we are going to build the application. Is it fine? Mapping the data basically means bringing the bit data down on the local system. Accessing the data is basically mapping the data. Next, what is important is cleaning the data. So whatever data you have got, you need to check the quality of the data. Now, within the quality, we need to check whether there is any missing value. We also need to check whether there is any noise in the data or there is any outlier. Just to give an example, when I say noise in the data, basically suppose there is one column which is talking about, suppose it is students data, and the first column is talking about roll number. Okay, so now roll number is a unique identity, right? So everyone will have a unique number, right? Okay, so suppose if everyone is going to have unique number, and if it is not going to play any part, first of all, it is not playing any part, so we can directly drop it. Okay, because this is not going to decide, okay, whether the student will pass or not, just to give an example, right? And here you can see there are n number of class because each variable itself is a class. Consider this to be a feature, guys. I'm not at all talking about output. I'm talking about features, input. Okay, so every variable is different, right? So every variable behaves like a class. So rather than having this data, we term this data to be noisy data. So if there is any noisy data, noisy means there are n number of classes, and we would like to go ahead and eliminate those kind of systems. Okay, so this is what we call as noisy data. Similarly, there can be missing data. Suppose you ask someone to fill the form and they did not fill the whole information in the form, right? And now you're using that information to go ahead and train the model. So if there is any missing data, you need to impute the missing data. Okay, so how do you impute the missing data? We are going to look into that in the subsequent sessions. Okay, similarly, outlier treatment. Now, what is outlier treatment? I'll just give an example. Suppose the people who are from the age 20 to 30, they have an average salary in US, which is equal to suppose 20,000 USD. Okay. Now, suppose this is the salary of people who are between 20 to 30, but at the age of 23, Bill Gates had a salary of, I'm just giving an example, suppose he had a salary of 10 million. Okay. USD. Now, do you think these people, and everyone is between 20 to 30, all these people are between 20 to 30. So, do you think if I'm going to build the model, the value of prediction, okay, will change for any other people who is going to be between 20 to 30 because of inclusion of Bill Gates? Don't you think this can happen? So, this person, it was more like an outlier. Okay, this person was extraordinary, but if I keep this person in my system, okay, then it can lead to you can say the information which might not be correct for the whole set of audience. Okay, so what we can do, we can transform the data on a single scale. Okay, if that can be a case, that can really be good. Okay, so if the frequency is huge, then basically means that outlier also plays a role, right? So outlier is basically there is something called as IQR, interquartile range, which we are going to discuss, and that will give you much clearer picture. Trust me. Okay, we'll discuss about interquartile range, which will help you understand how does mathematically we look into outlier. Then you will understand the science behind it, and then the things will be pretty easy. Similarly, all these things are part of data quality. I did say about data quality. See, we have specifically mentioned in the slide data quality. I did say that everyone does not fill the information correctly, right? So getting the correct information, okay, is also very important rather than just looking into missing, noisy, and outlier. So quality of the data is also very important rather than just quantity. Many a times you do know that at the time of audit, people do go ahead and say that just give the report, give the report, give the report, right? Okay, but you do know that giving the report will not go ahead and do the things easy for us, right? So quantity is not that important, quality is also very important. At the time of cleaning the data, we need to check the quality of the data, right? And for that we can have you can say setups, right, wherein we can show the data. Okay, we can pass the data to some people, okay, more of a stakeholder, and check, ask them whether this data sound to you is correct in quality or not. Okay, just give an example. Sampling is what plays part. Okay, many a time people come to us and ask, right, whether this thing is genuine or not. That happens with everyone, right? whether this is genuine or not. Why do we ask? Because we are concerned about the quality. So at the time of training the model also, the quality is very important. Okay, so now when I say transformation, again, guys, this is more of a understanding of pre-processing. When I say transformation, basically means many a times you might have seen data. I'll just give an example. Suppose I have temperature, okay, and suppose the temperature is in degree Celsius. Okay, now suppose I have temperature 32, 45, 88, okay, and 98, and suppose this is the temperature of the environment. Now have you seen an environment with 88 and 98? No, right? Generally, so basically we need to check what is the unit. This might be in Celsius, which was okay, but this might be in Fahrenheit, right? Okay, so the first thing, I'm just giving an example, guys. So the first thing is format conversion. Always remember, data across the column, first of all, data within the column should be same in unit. Very important. Okay, now once you have that thing in place, I'll just give you another example. So suppose I have got temperature. Okay, temperature is 32. Okay, 45. Suppose we have converted and then we have 30 degree, and I have got one more feature. I'm not going to tell which feature is this. I'll just write F, and suppose the value of the, I'll just give you the information also. Suppose this is price. Okay, price of price of AC car. Let me just put it this way. Okay, now suppose this is 32,000 USD and this is 45,000 USD, and suppose this is 80,000 USD. Just give an example. Okay, now I'm going to ask you, if I build, suppose if I want to predict y will be dependent. I'm just giving an example. Y will be dependent upon x1 and suppose these two are non-correlated. So y will be dependent upon x1 and x2, right? Let me just change. Sorry. So rather than price of a car, let me just say this as salary of a person. Is it okay now? Now this is why. So now what I'm saying, price of a car will be dependent upon x1 and x2, salary of a person and the temperature. I'm just giving an example. Okay, now let me just tell you something. Now 32, I'm just giving an example, guys. We will look into this. 32 plus 32,000. Now tell me, suppose if I build a model, first time it saw 32 and 32,000. Second time it saw 40 and 45,000. Third time it saw 80 and 30,000. Now tell me, which feature will it give more importance to, 32 or 32,000? Which feature will have more contribution towards Y? Now the point is, this may not be right because this is temperature, or maybe suppose this is age of a person. I'll just say suppose. Okay, this is age of a person. So that is where we need to normalize the data on a single scale. So if across the column, first I told format conversion within the column and normalization across the column. So suppose if age of a person and salary of a person is going to determine the value of a car, I'm just giving an example. So you will automatically understand that 32,000 is far greater than 32. So this will automatically approximate itself to zero, right? As compared to 32,000, right? So what is the important thing? Whenever you have this kind of a thing, you need to normalize. Normalize means bring each and every value onto a single scale. Okay, I hope that makes sense. Normalization happens within the column or across the column, wherein we bring everything onto a single scale, and format conversion within the column. Okay, similarly, statistical imputation helps you to evaluate the missing data value. So suppose if I have some amount of missing data, suppose 5% of my data is missing. Okay, out of 100 only 5 records are missing, so I can replace it by mean, or I can replace it by median, or I can replace it by mode. Now, what to replace with, we will look into that. So we can replace it by mean, median, mode. So now we know that mean and median are basically calculation. Okay. So just to give an example, suppose, I'll just give an example. Suppose the temperature, okay, 32, 33, 34, and 35. And suppose one of the person has not specified what was the temperature at his city. Okay, suppose this is blank. Now, the point is, what should I go ahead and do here? I can go ahead and take a mean. Mean is a mathematical measure, right? Mean is a mathematical measure. So 32 plus 30, 30, 30, 120. I can call it as 124. Is it okay? 124 by 4 will be how much? Tell me. 31, right? So the next value that I want, suppose this was missing, so I can assume it to be 31. Okay, this is called as mean. Okay, what is median? Suppose if two values are 33, then you can count which is the mid value. Okay, which is the mid value. So you will arrange everything in ascending order. Suppose I have got value as 32, 33, 33, and suppose 29, and suppose I have got something called as 23. Okay, now what are we going to do? First we will arrange it. 23 will come first, then comes 29, then comes 32, then comes 33, and then comes 33. Now if I'm going to ask you which is the middle value, this is the middle value. So middle value is basically called as median. So whenever you have numerical data, you make use of mean and median. But suppose I have something called as the person is non-diabetic, non-diabetic, diabetic. Okay, and suppose the person is suppose this is the missing value, and this is missing across the output column. Just give an example. It can be in the input column, it can be in the output column, because we can have 0 and 1 also in the input column, right? Now if I want to go ahead and assume what will be the value here, then I can make use of mode. Mode does what? Mode counts how many times 0 occurred here. Tell me. Twice. And how many times 1 occurred here? Only once, right? So now if I want to balance, I can replace it by 1 just to have a balance. Is it okay? I'm just giving an example. So that is where I was coming. Synthetic data has made this kind of things pretty easy now, because earlier what used to happen, when the data points were less, okay, we were bound to go ahead and substitute. Suppose if lots of values are missing, okay, and you need lot of data, so you need to go ahead and do imputation, because there is no other option, right? Okay, so we can do statistical imputation, and finally feature engineering. Now, what is feature engineering? Creating multiple features out of the given feature, or deleting some feature. So basically manipulating the features. Okay, manipulating the inputs. Okay, this is really different as compared to format conversion, data normalization. All these are manipulations on. But feature engineering is more like creation of a feature, or deletion of feature, or update of feature. Okay, we will look into this aspect once we move forward. Finally, one more important thing which is really important to be noted is sampling of data. Now, this is very important. Suppose the government told us to go ahead and find what is the average salary of people, okay, who are living in Mumbai. Okay, now Mumbai is huge. You went to the sector where the people are rich, okay, in Mumbai, and you found that all the people are earning 2 million, okay, per month. Just give an example, 2 million per month. And based on that, you went ahead and told that the salary of the people who are living in this Mumbai is 2 million, which is not going to be correct. So sampling of data is important. Some sample you take it from here, some sample you take it from here, some sample you take it from here, based on age, based on location. Okay, and then you create a sample which can be fitted. Very important. Data split, if you remember, I did specify you about data split, train and test data set. Okay, I hope that makes sense. Okay. One more important, very important term is data binning. What is data binning? Suppose I have a data. I'll just give an example. I'll just take it this way. So suppose I have a data set. Okay. And I want to, suppose rather than training and testing, I'm going to split it into 3. Okay. So suppose this is section 1. This is section 2 of data, and this is section 3 of data. Now, what is the purpose of splitting the data? Maybe at the first time, I am going to train the model with the first data set. With the second data set, I am going to go ahead and you can say test the model. Okay. And with the third data set, okay, suppose I am going to again test the model. Okay, or suppose I'm going to go ahead and reuse this data again and again. So basically binning is required when we want to go. Just to give an example, suppose I'll just give an example. Suppose I trained the model with T1, okay, T1 data, and it gave, okay, I trained the model with T1 data, okay, and tested the model with T2 data. Okay, after training and testing, suppose I got an accuracy of 0.9. I'm just giving an example, guys. Okay, let me just take it ahead again. So what was I saying? Suppose I have got 3 data set. Okay. So first I trained the data on data set 1, and I tested the model. Sorry, I trained the model on data set 1, and I tested the model on data set 2. And suppose I got an accuracy of 0.9. Second time I trained the model on data set 2, and tested the model on data set 3, and suppose I got an accuracy of 0.8. Third time I trained the model on data set 3 and I tested the model on data set 1, and suppose I again got an accuracy of suppose 0.95. Now tell me, all these are based on same machine learning algorithm, same type of machine learning algorithm like regression, and in that also we are using the same type. In that also there are different types. Okay, we use the same type, and for every type we got, what did we got? We got the accuracy as different. I hope you are able to see. Okay, now what has happened? I've just manipulated. So maybe I don't know which data I'm showing. Okay, if I show some data, the value can be different. So what will I be interested is, I'll say I want an average accuracy. I'm interested to get average accuracy. What is average accuracy? 0.9 plus 0.8 plus 0.95. This will be around 1.8, 2.65, 2.65 by 6 will be around how much? 0.88. I'm just giving an example. Okay. This is my average accuracy. Now tell me, if I would have, I'm just giving an example. If I would have gone ahead with this, what would have been my average accuracy? 0.8. If I would have gone ahead with this, it would have gone with 0.9. If I would have gone ahead with this, it would have gone with 0.95. But you know, in real sense, when you're going to put it onto production, you might be looking for an average accurate value, right? Making sense what I'm saying? And that is where comes data binning. Data binning basically means retesting the model on different bins of data that you already have. So train and test it with something else. Then train and then test it with something else. Keep on doing that rather than just going ahead and doing a simple train and test. So this is called as training and validation also. So I'm training, then I'm testing, and then to be very frank, we are also doing validation. And what I showed, okay, guys, I'll just give an example. Don't you think I was crossing 1 to 2, 2 to 3, 3 to 1? I could have also interchanged this also, right? Okay. So this type of things where we use binning is called as cross validation. Is it okay? Wherein we are interested to get average matrix value rather than trusting on a single matrix value. Okay. Average matrix value for different types of algorithms. So we will keep on training on different bins to be able to get the response. And this bin creation and then validating the model with an average value is more of called as, what do we call it as, guys? Do remember this, cross validation. Okay, I hope that makes sense. Splitting the data and binning the data is a two different aspects. Splitting is a part of binning only, but binning is not splitting. Okay, this is for point 1, point 2, point 3. So this all things are called features, and this is what we call label. Now what do? We pass this feature label to an algorithm which is going to go ahead and build a relation between this data that we have. Okay, so model encapsulates the relation between y and x. I already told you, right? Once this encapsulation has happened, try to understand. Once this encapsulation is happened, then you go ahead and try to inference upon this model. This is where we call testing the model. I am telling inferencing here, but I was using the same word as test the model. Now, what do you do at the time of testing? Think about it. You unlabel feature basically means you do not show the label. Okay, what do you show? Only the input, and then you ask it to predict. And though it is not shown here, then what do? You compare it with actual y. Okay, you compare it with actual y. Now, suppose, let me just take it this way. Suppose I told yes, yes, no. I hope you remember. We were trying to predict the class of an income, right? Of a person. Now, suppose I want to predict the price of a car. Now, tell me, suppose, just giving an example, suppose the price of a car, you predicted it to be 1,000, but in actual, the price of a car was 1,100. Now, here, what will be the difference? How will you measure? So, when it is classification, you measure it with accuracy. But when it is regression, don't you think it is a regression, guys? When it is regression, it will be minus, it will be mathematics of simple mathematics. 1100 minus 1000. So how much is the difference? 100. So this is what we call error. Earlier it was whether it is accurate or not. Here it is whether it is matching to the value or not. So here you try to find error. Okay. There you are trying to find accuracy. Just give me an example. One matrix I'm saying, guys, you will look into all other things once we go. I'm just explaining you things. So in classification, evaluation is based on metrics, which is one of the type is accuracy. In regression, the evaluation is always based on error. Okay. So if I say the perfect model, for a perfect model, what should be the error? Tell me. And for a perfect model, what should be the evaluation of accuracy? Okay. What can be the maximum value of error? It can be any. But what can be the minimum value of accuracy? Not less than zero. It will always come to zero, right? Because probability can never be less than zero. Okay. Now, I hope this also makes sense. Now, let me just take you ahead. We have already gone through this. So, what are types of machine learning? Supervised and unsupervised. What is there in supervised? Training data includes no label, right? Unsupervised, training data is unlabeled. Label basically means there is no target and here there is a target. Label means here there is an output to see and here there is no output to be seen. We'll just go with this one. Regression. What is the label? Label is a number. What is classification? Label is a category or class. Just to give an example, number of ice creams that were sold based on day, based on season, and based on weather. So there are three inputs. What are the three inputs? Season, day, whether it was Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay. Whether it was rainy season, whether it was winter season, okay, whether it was summer season. Okay. And sorry, this is season. Weather basically means what was the temperature throughout the day. Okay. Average temperature. So based on that, what are you predicting here? Predict the number of ice creams sold. So don't you think it is a regression? Number of ice cream. Now, if we say whether the ice cream was sold or not, this will automatically change to binary classification. Okay, simple. Now, just to give an example, predict whether a patient is at risk for diabetes. Okay, predict the species of penguin based on its measurement of the feather. Okay, they have feather, right? Wings. So, based on the wings, we want to predict what is the species. There are different species of penguin. Okay, if the weather is small, they are called by different name. If the weather is large, then they are called by different name. So here we are saying based on measure of something, we want to predict which class do they fall into. So this is label is one of multiple. Here the label is of, here we have specified whether it will be diabetic or non-diabetic. Okay, so we can have binary or multi-class classification. More than two class can also be possible, which can be a real case scenario. Okay, the output can have more than two class. Okay, then comes clustering. I told you about clustering. Someone gave me the data and told I don't know what to do. Just try to find some pattern. Okay, so similar items. This is also classification wherein we try to ourselves do similar item. We try to club it into a single group. So here you can see separate plants into groups based on same type of characteristics. Like plants have got sepal length, petal length, color, smell. Based on that, you have gone ahead and classified them into similar groups, similar to how you can classify a vehicle, right? Classify humans. Okay, the nature of human, you can have classification based on that. You can have classification of student based on marks that they score, okay, or based on number of hours that they study. There can be whole lot of classification without being specified. What to do is called as clustering. Okay, now I did say about this aspect. If you remember, we did talk about training and inferencing. Now just to give an example, we'll just look into this. What do we have? We have training data. We have create an algorithm which has a relation between x and y. So we have a training data, we use an algorithm to create a model. And then what do we do after creating the model? Okay, what do we do? We pass the validation data. Just look into step number 4. Step number 4 is all this. This is step number 4 from here to here. So what is this? We pass the validation data. In the validation data, we just pass this value first. Okay. And what do we get? We get the prediction. What do we get here? Can you see? We get the prediction. So what are we going to get? We will get y cap. Okay. Y cap we will get for first value. I'll just give an example. Y cap we will get for second value. Y cap, here there are three values. So just to give an example, y cap or y bar I'll get for third value. Okay. Now what to consider while choosing algorithm? Predicting categories. Okay. If you want to predict categories, what should be the best option? And if you want to predict continuous value, if you want to discover structure within the data, classification, but it is more of clustering. Finding unusual points in the data, clustering. Okay. Now, taking you ahead, skill required, just to keep it simple, you need to have soft skill. This is really important soft skill because you might be required to communicate with people who have domain knowledge because you cannot have domain knowledge of everything, right? So, domain knowledge, effective communication, okay, analytical skill, okay, curiosity and common sense, which is really not common, right, when it comes to machine learning. Okay, so common sense, keeping it simple. Okay, technical skill, I did say about mathematics, statistics. Okay, how to go ahead and call a file or get a handle to the database because you might be required to go ahead and pre-process the file, right? Then machine learning algorithm knowledge, having knowledge of Python, R, Julia, PySpark. Okay, then if you want to go ahead and visualize the data, you may use Python visualization tool or you can go with Tableau also or maybe Power BI. Okay, the point is very simple. Having technical skill with soft skill is important. Now, when it comes to soft skill, again, domain knowledge is very important. Communication with different stakeholders again comes very important. So everyone may not have domain knowledge. So if you communicate and can build upon that knowledge because you want to build a model, it is very important. Very important thing, analytical skill, trying to understand which variables can have relations. Okay, one more important, very important thing is curious, like how Vinay is asking, how other people are asking those questions, like what, where, how, when. Okay, any kind of WH questions that you have wherein you want to understand is very important. Again, having curiosity to understand what is happening at the back end. Okay, then one more important thing, it should, like many a time you need to go by the gut feel, right? I do go by gut feel. So is it making sense on normal belief? Okay. Okay, so common sense is again very important when you want to go ahead and build a machine learning solution. I did say about technical skill, mathematics, very important because it is the base for building of your model because it uses algorithm which encapsulates the relation between output and input or tries to find relation between your data. Okay, so basically algorithm is a part of mathematics. Statistics is very important if you want to understand your data, visualize your data. Statistics is important. If you want to work with data, wrangling means manipulating the data. Like if you remember data cleaning, data mapping, cleaning, transforming, and sampling, all this are part of wrangling the data. Okay. Finally comes machine learning. I did say that this is the heart. Okay. So heart of AI data science. Various algorithms are available within the machine learning, which can help you to predict the outcome. Once you're done with this, how do you encapsulate those machine learning things? You have libraries in Python, or you have Azure machine learning to directly go ahead and use Python directly on Azure machine learning, which is you see in DP100. Okay, so you need to build models. Okay, using any of the systems. Okay, then comes data visualization. This is very important if you want to communicate what you were able to find. Okay, very important again.
So that's a wrap for today's session on AI and machine learning. I hope you are now feeling excited and ready to dive deeper into the world of AI and start applying these concepts using Python. Also, if you're serious about advancing your career in these fields, make sure to check out our free masterclass in the description below. And if you really enjoyed this video, don't forget to hit that subscribe button. And check out our previous Python series over here and stay tuned for our next video.